we're going to talk about, okay, forming quadratic equations. Now, what this means is that they're going to give you a sentence or some sentences, and you have to answer the question they're posing by creating a quadratic equation. There are lots of different types of these, but I'm going to start you off with the most basic type, and then we'll get through as many as we can. Some of them are special situations where they use a pattern, and we'll look at them. But in order to make most of them work, you still need to understand the basic idea. Okay? So if you look, you've got some hints there. We're on page 53. You've got some hints there, and these are really good. So the first thing you want to do is call one of your values. And by values, I mean you could be looking for somebody, how old somebody is. You could be looking for how much somebody earns. You could be looking for how many people there are in a class. It doesn't matter. So that's what I'm saying, values, right? Call one of the values just plain X. Okay? So, Krisha and her sister, their ages are so much distance apart. How old is Krisha? Whatever, right? So if Krisha's one, you can just call plain old X. Okay? Well, then the other age, or ages, you could have more than one of them, right? It could be three sisters. The other age, okay? The other values are given, and look at this phrase, in terms of X. Now what that means is you're going to have an X in them. Okay? So one of them you're just going to plain old X, and we'll go through some examples here. Don't panic. Just write down the notes first, and then we'll go through some examples. The others are given in terms of X. And there are some key phrases that you need to be aware of so you'll know. Okay? So, if you see more than, or its equivalent, greater than, right? Bigger than, all of those mean the same thing, right? Then what you're going to get is X plus some number. So, for example, again, if we're talking about Krisha and her daughter, that's not right. Her sister is 3 years older than her. Well, then Krisha is X. Her sister has 3 more years than her, right? So that would be X what? 3. Plus 3. Plus 3. 3 more. Plus 3. Now, it's always X plus some number, not just plus 3, but X plus some number. Okay? Notice the X part always comes first. We can have the phrase less than, which you could also see as fewer. Anything that says less than, fewer, whatever. What operation do you think that is? Not add, but what? Subtract. So you're going to have X minus some number. Right? Krisha is older than her sister. Her sister is 3 years younger than her. That younger means less than, right? Okay? So it would be X plus X minus 3. Okay? Pardon? Oh, well, if you were equal, who cares? Just be X. Right. Okay? Now, double times 2. So 2X. Okay? You could have triple, but it's going to be that would be very unusual. Okay? And that'd just be 3X. Okay? A lot of times they won't say double, they'll say twice. Twice, same thing. Okay? We happy with that? So you're going to see these key phrases. But what do you notice about all 3 of these that I just wrote? What do they have in them? You can't just write 2, or you can't just write plus 3. It's X plus 3 or X minus. Okay? So be very careful about that. Okay? All right. You can also have things where you square or whatever. And we'll look at some different ones. Now, okay? You're usually going to get two answers. If you're talking about ages, and usually what happens is one of those answers will be positive and the other will be negative. We have to make sure to choose the one that makes sense. Now, don't just automatically assume that that means the negative has to go. Sometimes the positive has to go, right? But you've got to see which one. So if it's ages and you have a positive and a negative, which one has to go? Negative. Length, no negatives, right? Time, no negatives. Usually it's the negative value that has to go, but sometimes both values will work. Sometimes you get two positive values. Sometimes you'll get two positive values and you have to find out by looking at your original problem which one won't work. That's a really common one in geometry problems, which we'll look at.
She's no older than 10 and you get like one that's over 10.
Exactly. When you put it back in there, it comes in over 10 or something. Yes, exactly. Something like that. Or you'll get a side is x minus 5, and you get 4 as an answer. Well, 4 minus 5 would give you negative 1 for the side. Can that happen? So you see, it's not about the fact the 4 was positive, but if you plugged it back in, it made a negative value, so you'd have to reject it. Okay? Now, on the MCAT, when you do that kind of thing, if you reject an answer, you must say why. Right? If you don't, then you can kiss your excellence goodbye. Most of them you can kiss your merit goodbye. So if you reject an answer, you must say why. Okay? All right, so keep that in mind when you're doing the papers. So just look at a couple of these. All right. And there are some patterns that we want to talk about, but first we're just going to talk about finding about just regular old numbers. So just look at the bottom there on page 53. Mariama thinks of a positive number. Already it's restricting you, right? The number has to be what? Positive. So if I get a positive and negative, I'm going to have to reject the negative, and I'm going to have to say why, because her number needed to be positive, right? She squares it, okay? So she thinks of a number, okay? If she thinks of a number, we're just going to call that number what? X. She squares it. So square it. Now again, this is straight out telling you what to do. Then she adds 15 times the number she thought of. Adds 15 times what number? X. 15x. Okay. Her answer is 100. If you see that phrase is, that is always the equal symbol. Okay. So let's go back to those. If you see the word is, that always means the equal symbol. Okay. Now, is 100. What did I just do? What kind of equation? What? A quadratic equation, right? Okay. So I've created a quadratic equation. Does it have any brackets?
No.
Fractions?
No.
Like terms that are on each side? No. So I'm going to solve it by factorizing, which means I first have to set it equal to what?
0.
Does it equal 0 now?
No.
What do I need to do then?
Get the 100.
Yeah, I'm going to subtract 100 from both sides to get it away. Now, x squared, 15x, and 100, they're not like terms, so I can't really subtract 100 from anything except this side. But so that still means I need to put them together. And notice, it's always the x squared first, the x in the middle, and the number when? Last. If you don't put them in that order, then your factoring won't work. Okay? So make sure you're careful about that. Now, I have to factor them. So, how many terms? 3. So we're going to use AC. My A is 1, right? So that's 1 times negative 100, which gives me an AC of negative 100. I'm looking for the two factors of negative 100 that combine to make what? Positive 15. Thank you. 1 and 100 add to make 101 or make 99. Not what I want. 2 goes into it 50 times. Will they add or subtract to make 15? No. 3 won't go into it, but 4 will 25 times. They add or subtract to make 15? No. 5 goes into it how many times?
20.
Now, they add to make 25, but if you subtract them, you get 15. But I want a positive 15, so which one needs to be the positive? The 20. So does 20 minus 5 make positive 15?
Yes. What?
Positive 20 minus 5, yeah? Okay. And negative times a positive still make the negative 100 I started with? Yes. Negative times a positive still makes a
I get confused when you times
negative.
it together. I always think they have to times to make positive 15.
No, you're combining to make the... Yeah. Yeah, get the operation backwards. Be careful. Now, I could go through the whole process, but what was my A?
Oh my God, it was 1.
So do I have to? Nope. I can just take these two numbers and put them in the brackets. X minus 5 times what? X plus 20. Now, if that doesn't make sense to you, then just do the process. Okay? Now that I have it factors, I just need to set each one of those factors equal to what?
0.
Equal to 0. So x minus 5 equals 0, and x plus 20 equals 0. To solve the first one, I simply add 5 to both sides, which gives me x equals 5. To solve the second one, I'm subtracting 20 from both sides, which gets me x equals negative 20. And I'm done, right? What number was she thinking of? I got two answers. She was thinking of positive 5. Why do I reject the negative? Yeah. She was thinking
Wow. You solved the riddle.
of a positive. So that's why I had to reject the negative 20. Now, you'll write that as a complete sentence and write it out right? But I'm just going to give you a few words to make you remember that you have to do it. If you reject an answer and don't explain why, I cannot give you full credit.
So is this, if you've always got a positive and a negative, you always reject the negative?
But if I don't.
She said at the start.
What if she was thinking of a negative number?
Oh, she was thinking of a positive.
Yeah, it said at the top she was thinking of a positive. If she was thinking of a negative number, then I would have kept the 20 and thrown away the 5.
Can your explanation literally just be, it said she was thinking of a positive number?
Yes.
Is that it?
Well, I don't know. I might go a little further just because you know how these people are.
Yeah.
All right? You've done NCA a little bit now, so yeah. So it would be better for you if you were a little more if you'd explained it a little bit more. Okay? All right. Good deal. Let's look at another one. I don't want one of those. I want All right, let's talk about some other cases, because those are pretty straightforward when you're doing that. The only way to get better at them and pull out the information is to practice. But there are a couple of special cases that are always the same pattern. And let me tell you that these special cases or these patterns are very commonplace on the MCAT. You'll see them in the practice. You'll see them on the actual test. Miss Brader was saying, and she's had years of experience with this paper, she said that these kind almost always appear on every paper. Okay? All right? And I'll give you problems about these, and we'll talk about these. The first one is if you have even numbers. So what they're going to say is the product of two even numbers is whatever. Okay? They've given you everything you need to know. What's a product mean? Product is the answer when you do what operation, though? When you multiply. So product means you have two things multiplied together. So we have two things multiplied together here. Okay? And both of those things are what kind of things? Even numbers. Okay? Well, if they're even numbers, then it's 2x. Because multiplying by 2 creates an even number. Because what's the definition of even number? A number that's divisible by 2. So even numbers are going to give you something 2x. So All right, now, okay? So you can see even numbers. Even numbers just multiply, or any number multiplied by 2 is going to give you an even number. So if you want it to be even, multiply it by 2. Okay? Now.
Oh, so it would be like 7 and 2, but one of them has to be 2.
Well, no, what happens is, let me find an example and I'll show you. Okay? Now, the first one would be 2x. Okay? Now, if it's the product of 2 even numbers, they'll usually say consecutive. What does consecutive mean? One right after the other. So if you have even numbers, if the first one was 4, what's the next one? Okay? So the second one is going to be 2x plus 1 more. Now, I know you're going to think, no, wait a minute, it should be plus 2, but don't. All right? So if you do the plus 1, does that give you any other even number? Think about it. No. So 2x plus what? I was going to lead you into something. I screwed it up by telling you already what I was trying to make you discover.
What does that say?
Okay? Yeah.
Product of 2 even, circle around the 2 even.
2 even consecutive numbers. Okay? So the first one will be 2x. The second will be 2x plus 2. What if there was a third one? 2x plus what? 4. Okay? It's just a pattern, okay, that you're going to use. So if it's even numbers, the first one is always going to be what? 2x. The second one is going to be what? 2x plus 2, because they're even, so you have to add 2 to get the next one, right? So if the first one was 4, the second would be 6, and the next one would be what?
8.
Which is 4 units away from your first one, right? So it's 2, then 4, then 6, etc.
How would you use that?
There are problems where they're going to say the product, it'll say exactly that. The product of 2 consecutive even numbers is whatever. We'll look at some examples. I guarantee you'll see it. So we'll look at some examples.
The first or second or third?
Well, you just call the first one 2x, second one whatever, and it doesn't matter.
It's like,
We'll look at an example. Hold on. Don't panic. All right? It's a pattern. You like it when there's patterns, guys. Come on, trust me. Okay? Let's see. Hold on.
No, because if it's a consecutive even numbers, then it's 2.
yes, you can skip. Even so say,
Just like
Wait,
a
So this is number 3 on page 54. Matt thinks of a positive even number. Okay? He multiplies it by the next bigger even number. His answer is 168. What was the number he thought of? So he thought of a first positive even number, and he multiplied it by a second one, and his result was something, right? So this is question 3 on page 54. So what are we going to call the first, since it's a positive even number, what are we going to call the first one? 2x. And we're going to multiply by the second one, which is going to be what? 2x plus 2. And when he multiplies them, he's going to get an answer of what? 168.
No.
oh, it tells us.
He tells us that part.
But that equals like 4.
You're not adding them. It's product, which means you're what?
What the x is here.
Product means you're doing what? Multiplying.
X is like 80.
Right? So here we go. Let's set it up. It's product. So it's 2x. I'll write it in words first. Okay. It's the first one times the second one, and you better use brackets anytime you mean multiplication, equals 168. Right? That's what we're saying to do. Multiply the first one times the second one. So the first one is 2x times the second one, which is 2x plus 2. And those two multiplied together have to give you 168. We just created an equation. So what do I have to deal with first? Brackets. So 2x times 2x is going to be what? 2 times 2 is 4. X times x is x squared. 2x times positive 2 is positive 4x. And it equals what?
168.
There you go. What kind of, no fractions. What kind of equation did I create though? Quadratic. So we need to set it equal to 0 by subtracting the 168 from both sides. Which, yeah, he says yes. Which gives us 4x squared plus 4x minus 168 equals 0. Now we're going to factorize it. What's the first thing you look for when you factor anything? GCF. And look what looks common to all of them. 4. You have to test 168, but it'll divide by 4. Oops, sorry, I put it in the wrong spot. It'll divide by 4 as well. So they'll all divide by 4. Remember, no calculators on the test. Okay? So let's divide them by 4. 4x squared divided out the 4, you get x squared. 4x divided by 4, you get x. Negative 168. Okay, so we just divided out the common factor. How many terms left inside the bracket? 3. So that we're going to use the AC method. A is 1, right? So 1 times negative 42 is negative 42. We're looking for the two factors of that that'll combine to make the middle number, which is what? 1. We're just factorizing. Well, we're factorizing it. We set it equal to 0, and now we're factorizing it. But the first thing that happened was there was a common factor of 4. So I divided every single one of them by 4. Remember, common factors, you always have to do that first. And you could do it without dividing out the common factor, but then you would be taking 4 times negative 168, and you would get huge numbers that would be hard to find. It would still work. Right? Because it's an equation, you would still end up with the answer at the end. But you'd have to reduce you'd have to work with really big numbers. Okay? 1 and 42, will that work? Give us 1? No. 2 goes into it 21 times. That won't do it. 3 goes into it, who cares? 4 goes into it, who cares? 6 goes into it 7 times, and 6 and 7 will make 42. And we'll make 1, positive 1, as long as that's negative and that's positive. Do they still multiply together to make this? Yes. And remember, this is that shortcut one. If you do, remember. If you don't, do the whole thing. So it's x minus 6, x what? Plus 7. Set each one equal to 0. Solve this one by adding 6. Gives us x equals 6. Solve this one by subtracting 7. Which gives us x equals negative 7, which I'm immediately going to throw away. Why? It ain't positive and it ain't what? Even. So, throw it away. But you have to tell why. Why did you reject the 7 and keep the 6? All right. So you can either say it in the positive, I keep the 6 because it's the only positive one, only positive and even one. I rejected the negative 7 because it's neither positive nor even. Okay? All right. Now, what if it said consecutive odd numbers?
X, 2x plus 1.
There you go. Consecutive, well, not x. Okay, yeah, 2x, yeah. Consecutive odd numbers. The first one is going to be what? 2x plus 1. Because an odd number is an even number plus 1. Does that make sense? Okay. All right. Now, what would the second one be? Because the next odd number would be an even number plus 3. So odd numbers, you add odd numbers to them. Even numbers, you add what? Even numbers to them. Know these patterns. Even if you don't understand why it's happening that way, it doesn't matter. The first one is this. The second one is this. Memorize it. Once you use it a bit, you'll start to it'll start to make sense. Okay? All right? You're also going to have questions involving age. Always make the youngest equal x. And then do something to the other one. So they're older than that, so that's more than, or it's double their age, so that's multiplied by 2, or whatever. Okay? All right? Now,
In number 3, the answer was 6, but then if you times 6 by 8, that
What did we do?
2 times 6 is 12. That's 12 plus 14.
You know why?
We did it wrong.
We did it wrong. What does it say? It doesn't say consecutive there. It just says what?
Next better.
It just
We
says
did get it
even
right.
number.
We did get it right. Look.
But it says the next.
What now?
biggest.
We did get it right.
Nope.
We just did it.
Because what word's missing there?
But it says
It
next.
thinks of positive even.
Well, I understand, but it doesn't say consecutive even numbers. It just says he thinks of a positive even number. So it's just some positive even number. So you just call it x. And the next one was x plus what? 2. We did the wrong things. I'm sorry. I read the question wrong. So it's just x and x plus 2. Because they're just numbers. They're not consecutive even. It didn't say consecutive even.
He was thinking
Sorry.
12.
Okay?
That's what the book says.
Okay? I'm going to put this on your OneNote. Post this on your OneNote. So let's look at it. Okay? Now, it's about consecutive numbers. And you cannot, guys, focus on this. You cannot use guess and check. If you use guess and check and just say, I know the numbers are 35 and 37, and you just write that down without showing you're working, how you got it, you didn't write the equation, then the best you can do is get an achieved for that question. We can give you one achieved for one of those. If you do it once, we can give you an achieved for that one, but it gets a special notation. Now, if all you get are achieved for the rest of them, and you need that achieved to make your paper an achieved, we can't count it.
Mr. Southwall.
It's an evil system. I don't make the NCAA rules. All right? So, build an equation or you're going to be in trouble. Sorry? Okay? All right, hold on. Let me do some consecutive numbers. Okay. Now, just plain old consecutive numbers. She uses n here, but it can be anything. If it just says plain old consecutive, sorry. There you go. Sorry about that. So if it just says plain old consecutive numbers, you just use x and x plus 1. Because consecutive means one right after the other, right? So it's going to be one bigger. So it'd be x times x plus 1 if it was the product of 2 consecutive numbers. What if it was the sum of 2 consecutive numbers? It'd be x plus 1. Okay? Sum means add. Product means multiply. Okay? But be careful. Even numbers have to be written as 2n and 2n plus 2. Odd ones as 2n and 2n plus 1 and 2n plus 3. Okay? All right. Let me just stop it there.